So good evening, everyone. Once again, I welcome you all in this class of Wave on String. And this is our lecture number 6. Today we are full on energy. What about you guys? I am also on my full on energy. What about you? You also? Okay. Everyone? Yeah, okay. चलिए तो फिर we will start with the full on energy session. Okay. Wave on a string. So in the previous lecture, if I talk about, we have seen very important, very conceptual for explanation about the energy in wave. Okay. So we have seen it that energy in wave is not constant. And how it can be constant? Because wave itself is a disturbance of energy or momentum, which is traveling from one end to the another end. So if we have energy which is traveling from one to other side, then how can we say that this energy is constant? Okay. And also we have seen that if we compare SHM and wave, although in wave, if I talk about the simple harmonic progressive wave, each and every particle is doing SHM, to and fro motion about the mean position, and wave is moving in X direction. Okay. So wave disturbance itself is traveling in X and particle is disturbing along Y. Particle is doing SHM. If you talk about strictly about the energy of a particle, if you talk about energy of particle, so energy of particle is constant. Okay. In this expression that we have seen, if I talk about this particle or whatever particle you can consider, if we talk about this particle, this one, so for this particle number 1, we have the energy constant because it is doing SHM. And for SHM, the energy is constant. And also the relation between kinetic energy and potential energy. What was that? Just a second. Let me change the screen. So let me. If this color is visible to you, green color. For SHM, if I talk about for SHM, energy energy is constant. And for SHM only, potential energy U and kinetic energy is not behave as same, which means where we have the kinetic energy maximum, so it is not supposed to say that, or it is not strictly believed that at point where the kinetic energy is maximum, the potential energy should be maximum. No. Where the kinetic energy is maximum, potential energy is minimum in case of SHM. If the potential energy is maximum, the kinetic energy is minimum. Okay. And let me tell you one thing also. If this is x is equals to 0, the mean position, and here we have this extreme minus a and plus a, and this particle is doing SHM to and fro. So one thing you will note down that at extreme position, this, and second at mean position. So at extreme position, what is the velocity of this block? Can anyone guess? This block is doing a motion like this, and this. Okay, it is moving to and fro. So can you tell me, any one of you, what is the velocity of this particle at x is equals to a? Suma, Sashi, any one of you. Yoga has said that it is zero. Anyone else? I guess Divyans has something in his mind. Suma has also, but they are hesitating to answer. Do not hesitate, guys. Okay. So I'll move with, okay, Divyans and Suma has also answered. Thank you so much. Believe in yourself and answer. Okay. So extreme position pe, if you see the motion of this pen, na, this pen is also in SHM, let's say. So if you focus on the, if I slow it down by 100x, so you will see this pen is moving like this. If my nose, look at my nose, if my nose is the mean position, so this is doing SHM about my nose. So when it reaches the extreme, you will say momentarily it came into rest. So the velocity of any particle which is doing SHM at the extreme position, the velocity of the particle is zero, whatever the frame you have taken. Okay. So we can say that at this extreme position, kinetic energy is minimum, which is zero. Kinetic energy is zero. And what is potential energy? Potential energy will be maximum because total energy is constant. E is equals to, just a second, E is equals to K plus U. So if K is decreasing, U will increase because E has to be constant quantity. This is equals to like this, 10 is equals to K plus U. So if K is decreasing, U must be increased so that the value, this sum will remain constant. This is for example. Now, if I talk about at mean position, again, look at the motion of this pen. So anyone tell me what is the velocity at mean position? Like either in terms it is zero or not. So yoga is saying that it is maximum. Obviously, the velocity at mean position is maximum. So we have as maximum value. So kinetic energy will depend on only on the velocity and mass. Mass is constant. Kinetic energy, velocity is maximum. So kinetic energy will be maximum. Now, what about potential energy? So you are saying that potential energy will be zero. Devyansh and Yoga. Sashi also. Suma also. Hema Sundar also. Okay. So everyone is saying that potential energy is zero at mean position. But I am saying that no. No. Something is missing. And who is going to tell me what is that something? Now, Yoga, you are switching your answer. You are saying minimum. Okay. So that something I will tell you. Great, Yoga, you have guessed it right. To write up the expression for potential energy, what do we need? We will consider a reference line or a reference point. From that point, we measure the potential energy. Exactly potential energy we can't define. Only the potential energy difference is definable. Okay. That we can only define. That difference of potential energy. Change in potential energy. And to know the exact value of the potential energy, we will take our reference at infinity and we will consider that at infinity, the potential energy is zero. The concept here is that the taken away is that at reference point for which we have established to measure the potential energy, at reference point, the potential energy will be zero. But have we considered any reference point here? We can measure the potential energy at this point. We can measure the potential energy from this point, from this point. Okay, there is no restriction in that. So in that case, if reference point is not mentioned, so we can say that potential energy will be minimum, not zero. And when it will become zero? When reference point is defined. And generally, in case of SHM, the mean position will be considered as reference point. That is the easy guess. Okay, got it? Each and everyone? Okay. So anyone, any kind of doubt if you have, you can ask right now. Okay. Now, for wave, is energy constant? No. Energy is variable. Okay. And second point is that U and kinetic energy will change together, which means when U is maximum, kinetic energy is maximum. And when U is minimum, kinetic energy is minimum. That we have discussed in the previous lecture. Okay. Can I show the expression to you? Okay, so this is all we have did in the previous session. Just a second. Yeah, this one. So we have find it out that total energy per unit length d by dx is mu a square omega square cos square omega t minus kx. So from here we can say the potential, so the total energy will depends on t and will depend on x, which means it is a variable quantity. Got it? And if you, let's say if you fix the x also at x is equals to 2, then also you have a variable as time, which means energy is not constant in wave. Okay. And the second statement that potential energy and kinetic energy will move together is this: du by dx is equals to dk by dx, which means when we have potential energy maximum, the kinetic energy will be maximum. And let me show you this, just a second. If this is the wave, let me change the color here. If this is the wave pulse, and originally it is at like this. So if you talk about this position, we have considered very small length. Okay. For your reference, for you to understand it well, I have considered this length a little bit large. Okay. Although it is very, very less. Got it? So we have considered one of the particle, one of the position is this, and one of the position we have considered this. dx1, dx2. Now, if you project it on the upper side, so you will find out this length and this length is same. Okay, which means there is no stretch in the string. If there is no stretch in the string here, there is no stretch in the string, no stretch, so no potential energy. Okay, energy will be stored when you stretch the wire, you stretch the string, you stretch the spring. That in that case only the potential energy will be stored. In the case of spring, it will be stored in the compression also, in the squeezing of the spring. But in the case of string, only in the tension case. Okay. So in this position, we have what? U minimum. Now if you talk about this this position की kinetic energy, so kinetic energy we will have as particle की kinetic energy. So this particle is doing SHM about this line, and this is the mean, this is the extreme position. इसके beyond particle will not go. Okay. So at extreme position, as Yoga and Divyansh and everybody has answered, that at extreme position the velocity is zero, which means kinetic energy is also minimum, or you can say zero. Okay. If you talk about this one, the particle that is present here initially, this particle is traveling, this particle is oscillating. Okay. And wave is traveling in this direction. Now if you talk about this one, project it, so you have this much amount of length. This much amount of length is definitely greater than this dx1, and this is the maximum stretch that is possible at the mean position. Got it? So if the stretch is maximum, the potential energy will be maximum, and at mean position, as everybody has answered, the velocity of the particle will be maximum. So here we can say the kinetic energy is also maximum. So energy here is also doing SHM type of thing. 0 to 100, 0 to 100, 0 to 100. Like if I assume 0 is the minimum energy, sum of this k plus u, and maximum is the u plus k is 100. Okay. So energy is also traveling like 0 to 100, 0 to 100. So this particular particle, let's say any of the particle in the string is storing a amount of 100 joule of maximum energy, and then it come back to the zero position, and in that process it will transfer this energy to the next particle. Again, when this particle has 100 joule of energy, this particle will be has zero. When it is decreasing in the energy, it is increasing. Okay. Got it? When this particle 1 achieve the zero energy, it will go up to the 100. So you will see that 0 to 100 again, 0 to 100 again. So the energy is also traveling in this direction. Anyone, any kind of doubt in this? किसी को भी, किसी भी तरह का, anyone? I don't think so, because you guys haven't answered this. Okay. So this concept is clear to you? Revision part? Now. Just a second. Got it. Got it. Thank you. So we have seen the power also. Power here is the instantaneous power that we calculated, mu a square omega square v. V here is the wave velocity. Okay. Cos square omega t minus kx. Now, average power we have calculated for one cycle, and I have told you that average value of sine theta and cos square theta sine square theta is 1 by 2, and the sine theta cos theta, it has 0. So power average we have mu a square omega square v upon 2. Got it? And this expression you need to remember. Okay. This one. Intensity we have created, and we have understood it well by the energy diagram that I have shown you. Okay. Anyone want to revise it again, that what is intensity? Or I will just move on. Anyone want the revision of the intensity? Okay, so you guys have understood it well, I think. Got it. So intensity is nothing but energy transmitted per unit area per unit time. Energy per unit time is power Power upon area is intensity. Power का expression we have as average power here. Area we have write it like this. So from here, this expression you also have to remember that intensity is 2 pi square rho f square a square. And यहाँ से important take down क्या थे? Important take down थे. Intensity is directly proportional to 1 by r square. R is the distance from the source. Okay. And A is the amplitude is directly proportional to 1 by R. Got it? Now we have to cover today principle of superposition and reflection of waves. In this, we have to learn about the principle of superposition, interference, and reflection of waves. Got it? Now, firstly, the principle of superposition. And this term you will see in various chapters in physics. Superposition of charges, superposition of wave, this not this wave, superposition of light wave. Okay, in the wave optics chapter in 12th, you will also see this principle of superposition of wave. Okay, and in electrostatic you will see the principle of superposition of electric field. Got it? So this is the concept is same there, only the physical quantity will be changed. So we will understood it well here. What is the principle of superposition? Now firstly see this animation. This will help you. Now here, firstly see this, then I will explain it what it is. So everyone seen it? Now in the very first case, if you will see, we have sent two pulses of different amplitude. Amplitude is the maximum displacement of any particle from the main position. So this much I think this is the maximum displacement. This, let's say this is y1. Okay, and in this case the this particle has the minimum maximum, this is y2. Okay, so these two wave pulse we have sent in opposite direction. Now what is happening in this case? If I talk about the very first case, let's say this one. So if you will see, when these two wave pulse, this one and this one, meet at this place, the final resultant pulse will go this much of length here. Observe it again. This one. आप यहाँ ध्यान से देखना, these two pulses are meeting at this place. So what is happening? The displacement got bigger than the initial one, which is given here by this and from here. So this final displacement that we have is, देखो, it is moving away from the maximum displacement of this, which means कि by sending two wave pulse in the opposite direction, but in what we can say, but in same phase, they are in same phase but moving in opposite direction. This pulse is also upside, this pulse is also upside, so they are in same phase but they are in moving opposite direction. So what we can say, the displacement or the final amplitude or the displacement of the particle will depend on that from where and in which phase the wave pulse is coming. And final amplitude, we have the algebraic sum of the initial amplitudes. As you can see, in the previous case, this wave has also in upside, this wave is also in upside. So resultant y resultant will become y1 plus y2, and that is why this displacement is going beyond this maximum displacement. Got it? But in case of opposite of it, these are moving in same direction, so the amplitude will go high. And when they are moving in opposite direction, one is up, one is low, so you will see the displacement goes nullified. Okay, same direction having maximum amplitude, the amplitude will up, and opposite direction mein amplitude will go down, amplitude will decrease. So this is we have as principle of superposition. So at a particular point in the medium, the resultant displacement of the particle produced by a number of waves is the arithmetic sum of the displacement produced by each wave. Okay, got it? And we have seen it. This one, let's say, these are the two wave pulse in the previous example that we have taken. This has a displacement y1 and this has a displacement y2. Now, according to the principle of superposition, the resultant displacement, let me change the color here. Resultant displacement, this one, produced by a number of waves is the arithmetic sum of the displacement produced by each of the wave. So here we have two wave pulse. Okay, only two wave pulse. So the resultant displacement will be given by y is equals to y1 plus y2. Only arithmetic sum. What is the difference between arithmetic sum and vector sum? There are two types of sum that you will get to know. First is vector sum, second is arithmetic sum. In vector sum, you need to consider the direction also. But here, in the arithmetic sum, you don't need to consider the direction. Only the magnitude you will have to take. Got it? So y is equals to y1 plus y2. Got it? Now again, if you will see, this particle 2 is moving in this direction at t is equals to 0. And this is also moving in opposite direction, but in opposite amplitude. Okay. It has amplitude in positive y direction. It has amplitude in negative y direction. Now let's see what will happen. At t is equals to 1 second, what will happen? This will move 1 second further. This will also move 1 second further. Again, at t is equals to 2 seconds, they will come like this. So what we can say, y resultant here will be y1 plus y2. So y1 is this and y2 is this. Okay. So this is in positive y direction, so we can write it as y1. This is in negative x direction, negative y direction, so we will write it at y2. And since y1 and y2 is same as y, so resultant amplitude will be 0. So you will see it that y resultant here will be 0. Got it? Now, so anyone, any kind of doubt in this principle of superposition? You are free to ask if anything you want to understand. Anyone? Is this clear to everyone? Okay. Three condition. What do you mean? 1 second. Okay. So okay, got it. I'll explaining it. Now what we have the principle of superposition is, just a second. Okay. So the principle of superposition that we have two wave. This is wave 1 that we have, and this is wave 2 that we have. And let's say it is moving like this. Okay. It has a displacement y1. It has a displacement y2. Now, what does the principle of superposition say? That if these two waves collapse, okay, in the same string, you start with this and your friend start with this also. So these two waves are moving with each other towards each other. So what is the final resultant when they meet, when they superimpose? So that is given by the arithmetic sum of the displacement. Now, this is arithmetic sum, which means you need to consider the sign only. We have measured this in positive y direction. This is plus y, this is minus y. So if they will superimpose, you will have a superimposed pulse like this. Got it? So this is, let's say, y. This is also y, but this is negative y because we have measured it into minus y direction. This is plus y. So here the y resultant, if you will see, it is y minus y, which is equals to 0. So in that figure, if you will see, in that figure, this color is somehow faded, which means that we have a straight pulse here. We have a straight pulse here, this type of pulse. The resultant here for this instant only will become 0. Same you can see in this expression. In this, when they are moving in same direction, the final resultant will be up. When they are moving in just focus on this green particle. When they are moving in opposite direction, focus on this. Same direction increases, opposite direction may, you will see that it is decreased. Got it? Now I think it is clear to you. This particle pe you can also focus. Just a second. Yeah, this is moving here. And in the opposite side, may if you will focus, it is moving very less. Got it? Now that we have covered already, interference may we will talk about. So interference is nothing but the application of superposition principle. Got it? Now, so as you can write, as you can see in the definition also, interference between two or more waves is just the addition or superposition process which results in a new wave pattern. Okay, so that process in which we take two waves and these waves superimpose with each other, either it is plus, either it is minus, and in that respect, the final amplitude that we will got, because the resultant amplitude will be disturbed, both the wave moving in opposite direction. So one is moving up, one is moving down. So the resultant will decrease. If both are moving in positive y direction, so resultant will increase. So the final wave pattern that we got will be decided by that what is the final value of resultant with the help of superposition principle. Okay. And this phenomena is termed as interference. Okay. Due to superposition principle, the new wave pattern that we are getting, this process is termed as interference. Okay. Now let's see. Let's say this is the equation that we will consider. Y1 is equals to a sine kx minus omega t. This is the general wave equation that we will consider. Now the next equation. So this is the wave kx minus omega t, which means this wave is moving in this direction. I have told you. in the positive x direction. Let's say for particular particle, the displacement is y1 at time t1. Okay. Y2, we have considered another wave equation, which is a sine kx minus omega t plus phi. Plus phi means these two wave has a phase difference. These two wave has a phase difference, and which results in what? Phi. Phase difference होने की वजह से क्या होगा? If you will see, these initial points are not coinciding. This wave has started somehow later. Let's say this wave has started from this at t is equals to 0, but this wave hasn't started at t is equals to 0. This wave started at some time after 0. Got it? So we can say that these two wave has a phase difference between them. When this wave achieving the maximum displacement, this particle is achieving the maximum displacement, this particle is at somehow lesser than the maximum displacement. So we cannot say that these two equations are same because they have a phase difference. Got it? Now, according to the superposition principle, what will be the resultant? What will be the resultant? Let's say this is y2 at time t1. Now, if we add them, we will have a final wave pattern like this. Okay, different amplitude we have here because the amplitude will be disturbed by the superposition principle and will be calculated by the superposition principle. So we can apply the principle of superposition here. Y is equals to y1 plus y2. Now, y1 की equation we know, y2 की equation we also know that we have considered. So if I apply the principle of superposition, y is equals to y1 plus y2, we have this expression. So if you take a as common, you will have sine c, sine d. And the formula that you have noted down, sine c plus sine d, I think you are aware about this formula, equals to 2 sine c plus d by 2 into cos c minus d by. So have you aware about this formula? This formula you have learned in your class 10th and 11th trigonometry. Okay. So this kx minus omega t you can consider c. This kx minus omega t plus phi you can consider d. Okay. So this same thing. So when you calculate this, let me calculate it for you. I think red ink is visible to you. Y is equals to a sine omega t minus kx. Sorry, kx minus omega t, I think it is written. Let me check. Yeah, kx minus omega t. So y1 is equals to a sine kx minus omega t, and y2 we have as a sine kx minus omega t plus phi. Applying the principle of superposition, principle of superposition. So what we will get? Y is equals to y1 plus y2, which is a I have already taken common, sine omega t minus kx plus sine omega t minus, just a second, I have reversed it, kx minus omega t, kx minus omega t plus phi. Now this is a sine c plus sine d, 2 sine c plus d by 2 kx minus omega t plus kx minus omega t plus phi divided by 2 into cos kx minus omega t minus d. D is this. So it will become minus kx plus omega t. Sign will change and minus will multiply minus 5 by 2. So if you will see, this omega t and omega t will cancel out. This kx and kx will cancel out. So only thing that you have is cos minus 5 by 2. And we know that cos minus theta is always equals to cos theta. So resultant that finally we have is y is equals to 2a, this 2a cos pi by 2 into sine. This kx and kx will be 2. This omega t and omega t will be 2. So we can say kx minus omega t plus 5 by 2. So this is the resultant wave pattern that you will get after the superimposition of these two waves, y1 and y2. But y1 and y2 is the displacements of particle present at position x and at time t. Got it? If you see, that itself is representing the displacement here. Why? This is the amplitude 2a cos phi by 2 because phi is fixed. Phi is not changing. Phi is fixed. So this whole quantity you can treat it as amplitude. Got it? Everyone? किसी को कोई doubt है इसमें? Anyone? In this expression that how we get it? Anyone any kind of doubt? Suma, Shashi, Divyansh, Ramnagar students. Anyone? Yoga also. Okay. Thank you. So this I am talking about. We have this 2a cos phi by 2 sine kx minus omega t plus phi by 2. So this is the resultant wave that we have. Okay. Now, this we can consider 2a cos phi by 2 as capital A, which is the amplitude, and this is the phase of this resultant wave. Now, so we, based on this K, we have two types of interference. First is constructive interference and second is destructive interference. So when you see in the previous animation, we have seen the wave pulse which is coming in the same direction. The maximum amplitude will go high or the amplitude is increased because of superposition. Okay. So that type of interference we can say it is somehow constructing. So it is a constructive interference when the amplitude is maximum. When amplitude is minimum, and which is in case of when one wave is traveling like this and another wave is traveling like this. Okay. So in that case, we have minimum value of amplitude. So that interference will termed as destructive interference. So for constructive interference, we know the equation of wave. Y is equals to 2a cos phi by 2 sine kx minus omega t plus phi by 2. If you simply focus on this amplitude, which is 2a cos phi by 2, this is the amplitude. So constructive interference happened when A is maximum. So for constructive interference, A will be maximum. When will the A be maximum? This expression depends on this phi, cos phi by 2. It will be maximum when this cos phi will become 1. Anyone? Any kind of doubt in this? because this A depends on this cos phi, and this cos phi by 2 has a maximum value of 1. So the amplitude here is A will be maximum when cos phi by 2 will become 1. Cos phi by 2 will be 1 when, for what values? Cos 0, cos pi. Okay, these type, for these values this will be 1. Cos pi is minus 1, sorry. For cos 2 pi, 4 pi, 6 pi, these types of value may, this will be, we can say 2n pi. Okay, so this is I want to discuss with you. I have written it also in this form of typing form. I will explain it now with this. Now, these wave we have with the same amplitude in same direction. If we add them, the amplitude is higher than the each of one which we have taken previously. Got it? Now, A will be maximum for constructive amplitude. A is equals to 2A, and it will happen only when cos phi by 2 will be 1. That I have discussed. So it will be maximum 1 for phi by 2 is equals to 0 plus minus pi plus minus 2 pi this. So we can say that for phase difference, phase difference for constructive interference should be phi is equals to 0 plus minus 2 pi up to this value 2n pi. So general expression we can say that phi is equals to plus minus 2n pi. For these values of phase difference, there will be a constructive interference in the wave. Got it? Now the destructive interference. So you can guess it easily. Destructive interference is happened when the amplitude will be 0 or minimum, you can say. Let's say this is the wave, and this wave is traveling opposite to this. You will see this is upside and this is downside. When this is downside maximum, it is upside maximum. So this will collapse and give you a resultant wave like this. Got it? Because by applying the superposition principle, y is equals to y1 plus y2. Y1 we have as a, y2 we have as minus a. This will be 0. So straight line you will get. Okay. For destructive interference, we can say this cos phi by 2 will be minimum. And for this a to be 0, this cos phi by 2 will be 0. And it will be happening for pi by 2 and other values. Okay. So it will be 0, 4 plus minus pi by 2 plus minus 3 pi by 2 plus minus 5 pi by 2 for all these. Okay. So if we generalize this, we have phi is equals to 2n plus 1 into pi. So if you put n is equals to 1 here, sorry, 0 here also. So you have phase difference y is equals to pi. Got it? N is equals to 0 pi, you have pi. N is equals to 2 pi, you have 3 pi. Sorry. For n is equals to 1, you have 3 pi, then 5 pi, then 7 pi. So for odd multiple of pi, you have a destructive interference. And for even multiples of pi, you have a constructive interference. This thing you need to remember. Okay. Now, this question you can see. If two waves y1 5 sine kx minus omega t plus pi by 6, y2 is 5 sine kx minus omega t plus pi by 2 are superimposed, then calculate the resultant amplitude. What is the resultant amplitude? You can easily calculate it by the principle of superposition. Firstly, the phase difference is pi by 3. So the resultant wave that we got is y is equals to 2a cos phi by 2 sine kx minus omega t plus pi by phi by 2. That you can apply. You got the value of phi here. So the resultant amplitude will be 2a cos phi by 2. Okay? This value. Got it? And if you would like to write the equation for that also, you can write y is equals to 2a cos pi by 2 sine kx minus omega t plus pi by 2. So if you put the value of phi here, you will get the equation also. Okay. Now, the reflection of wave. अभी तक, for now, what we have discussed, the wave that is propagating in an unbound medium. We haven't considered the boundary situation. Either the string is tied to the end or it is loosened at the end. We haven't discussed this. Okay. But now we will be dealing with this. And that is termed as the reflection of wave. Okay. So what will happen when a pulse meet at the boundary? And that boundary will be rigid and that boundary will be free boundary. Okay. What we will see, that you have a string or a rope, you have tied it with a collar is of a shape like a ring. Okay, so one of you and you have tied it with, and this ring you have placed inside a vertical bar. So this collar can slide inside that vertical bar. So this end, this boundary will be considered as free boundary, because this end will not resist the wave. But if you have the metallic bar here, you have a support here, let's say a pillar, and you have tied the spring or tied the rope to it very tightly so that it cannot move up and down. So that will be considered as the rigid boundary. Got it? So 2 minute ka ye topic hai. We will cover it up very separately. If you will see this, and we have tied it well with the help of this. Okay, with the help of this device, we have tightened it. Okay, this is termed as, I think, bench press. Bench, I think. So when a wave get reflected with this solid boundary, you will see in this, it will get started from the bottom. Okay. So when a wave get reflected at solid boundary, the reflected wave has a same shape. Shape is not disturbing, if you will see, as the incident pulse, but it suffers a phase change of pi or 180 degree on reflection. Okay. So firstly, it is moving from upside. Now it is moving on downside. So if you will see, initially the particle is here. Finally, after reflection, particle is here. So what is the phase difference? This angle is pi, we can say. Okay, got it? So remember one thing, when the wave is reflected from rigid boundary, it has a phase change of phi. अगर वो ऊपर से जा रही है तो रिफ्लेक्शन के बाद it will come down, and if it is coming down reflection के बाद it will come up. Okay. Now, so why it is happening? It is exerting the pressure or a force on the rigid end, but rigid end cannot move. So it will also apply a reaction force to this. And due to this reaction, all the pulse will get reflected to the downward direction. That is why this is the force applied by the string. It will, the string want to pull up this knob which we have tightened it. This want to pull it up, but this is fixed. This is the rigid boundary. So instead of that, the rigid boundary will also apply a force in the opposite direction. This is the rigid end, and that is why the generate a reflected pulse that differs by a phase of phi. But this will not be happening in case of so if you will see, this is the equation for incident wave pulse, and this is the final wave pulse with the phase difference of pi. Only pi will be added. And also if you will see, this will got plus because it has changes the direction also. Okay. Both, just a second, both omega t and kx is positive. So the wave is moving negative direction. We will write it in this expression. Now for free boundary, if you will see, firstly you will see. So for free boundary, there will be no phase change. Okay, there will be no phase change. Same phase hoga, there will be not any change, because here there is nothing to resist the force applied by the wave. Okay, only the direction will change, not the amplitude, not the phase. So if you will see, initially it has applied by this force. So this end that we have tightened here will move up. Again, it will move up, and finally the string was stressed, and due to this tension, it will get back to the original position like this. Okay. So if the equation is this, what will be the final equation? A sine kx plus omega t. Both the side is plus, so it is moving in negative x direction. They are opposite signs, so moving in positive x direction. Okay. So this is it, guys, for today. If anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. Okay. Take care of yourself. Any kind of doubt, if you have, you can ask. Okay. Thank you so much. Bye bye. Thank you so much.